Algebra 1, we are going to solve this equation using the quadratic formula. So let's review for just a moment because we have learned two ways already to solve a quadratic equation. We've learned to solve by factoring, and we have learned to solve using the square root property. So first of all, we can take a look at this and see that it's not factorable. We have 2 on the front and 1 on the back. And there's no combination of 2 times 1 and 1 times 1 that's ever going to add up to 8. So this is clearly not factorable. It's also not a good candidate for the square root property because it has a linear term or an x term. So we need something different. We need the quadratic formula because the quadratic formula works every single time. It may not be the most efficient, but it works every single time. So first, let's write the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. You absolutely have to know that. You have to know that for Algebra 1. You need to know it for geometry, for Algebra 2, and for any science class that you're going to, upper level science class you're going to take. This is never going away. It is a very fundamental part of algebra. So, just like we learned in previous sections, we need to know a, b, and c. Well, the leading coefficient is a, the linear coefficient is b, and the constant is c. It's the same a, b, and c that we have already been dealing with. So a is 2, b is negative 8. Remember to take note of the sign that precedes the number, and c is positive 1. So there's our a, b, and c, and we are going to start plugging them into this formula. Yes, it is a formula, and we are solving for x. X equals the opposite of b. b is negative 8, so the opposite of negative 8 is positive 8. Plus or minus. Yes, we're using a plus or a minus because this is a quadratic equation and we're expecting two solutions here. So 8 plus or minus the square root of b squared. Now, in my head, I like to go ahead and square b. So if b is negative 8, then negative 8, the quantity squared, is 64. There's no need to write negative 8 squared in there. Just go ahead and square b and plug it in and save yourself a step. Minus 4 times a times c all over 2 times a, which is 2 times 2. So there's our first step, just getting everything plugged in. Now we're going to start simplifying using order of operations. Remember, the radical sign is a grouping symbol, so we need to do what's underneath first. So underneath we have 64 minus 8. We've got to do the multiplication first before we do the subtraction. And of course on the bottom, 2 times 2 is 4. Let's keep going underneath that radical sign. And what's underneath that radical sign is b squared minus 4ac. We're going to talk about it a little bit later in this section. It's called the discriminant. So we've got 8 plus or minus 64 minus 8 is the square root of 56 over 4. We're almost there. We just need to simplify the radical next. So we've simplified radicals many times. We're going to make a factor ladder. So 56 divided by 7 is 8. 8 divided by 2 is 4. 2 and 2. So 56 is really 2 to the third times 7 to the first. Remember that radical has an index of 2, and we're going to simplify it the same way we've been simplifying it by comparing those exponents. 2 goes into 3 one whole time with 1 power of 2 left under. 2 goes into 1, no times, so the 7 stays under. So the square root of 56 reduces to 2 square root 14. So 8 plus or minus 2 square root 14 all over 4. Now, why does this equal what it equals? And why can't we simplify it? Well, I just want you to see on the graph very quickly, if we were to graph this, so going back from 0 and letting it be equal to y, if we graph this quadratic equation, I'll show you what it looks like. So there's the graph. Now, if we take it to a different picture, I just want you to be able to see, and I will zoom in on the graph. What we can see here is that the x-intercept is not at a whole number, not on the left nor on the right. If I use the trace function, I can get pretty close to it. It's kind of jumping over it. So let's try another button, and you're going to learn a lot about this in Algebra 2 next year. I can find a 0 here, so let me get on the left of it and on the right of it. And I can see that this point where it crosses the x-axis is actually at 0.12911713. So let's take this crazy fraction that we've got on our paper here and see if we get something close to approximately 0.12911713. And let's see if one of those equals that. So obviously it's not going to be 8 plus 2 root 14. So let's try the other one. So I'm going to put this in as a fraction, and yes, my calculator has all sorts of magical buttons. So 8 plus 2 times the square root of 14, and put that over 4. Oh, I really wanted a minus, so let me go back, not that far. I want that to be minus. And then as we get out of here, look at there. It's exactly the same thing. That is an irrational root. It's irrational because it is a non-terminating decimal. It's just going to go on forever. It's very irrational. So that's how we use the quadratic formula, and these are the graphs that the quadratic formula helps us to understand.